Alright, well while we wait for your peers to get here, I guess we can do an Ask Me Anything. So, what do you want to know?
Lady's got a card.
Oh, well, I already asked the one question I wanted to know.
Take it with you, I'll collect them in a minute.
Oh, yummy snacks.
Yeah, so go ahead and put your name somewhere on the handout.
Do we follow where the cards are?
Yeah.
I get this.
I found yummy snacks.
Actually, if you have an ace, go to the table that says 9s. If you have a...
Hey, Mr.
I'm
Hudson.
joking, you just asked a funny question.
I found yummy snacks.
Nice.
They're mine now.
Probably not, because we'll be working on the handouts.
They're my yummy snacks. Cherish them forever.
That's what you'll add next.
And ever. And ever. Until I use them.
So you gotta keep
And then I
pushing.
will cherish them.
Do you think that's mastered? Do you think
I
that's...
really like saying this.
Alright, does anyone have any questions for me? Otherwise, we'll dive in once we're all here. 4, 7, hold on. We're almost here. Alright, who had a question for me? But yes, the answer is totally yes. Did you get a card at the door and a handout? Yeah. So guys, start to get in the habit when you walk in. Check that front table at the door. It'll probably have things there that you need to grab. Hey gentlemen, when I start talking, you stop and I'll give you the same respect. But what did I just say? Previous to telling you to stop talking. Can somebody enlighten our gentleman that we're talking with what I just said?
Please try to make a habit of looking at that table to see if you need to pick up anything.
So we're trying to build these daily processes, right? So the next daily process that we want to build is open your binder to your plan book. And in your plan book, your homework that you're going to write down is explore growing squares. So I'll write it up here and then I'll put one up on the homework board. But it's sitting on your table. These go up here. We're going to talk about that too. Explore growing squares. Other stuff to make sure that you guys are aware of for the classroom. A lot of times I have like a random stack of paper here, but my extra paper that is organized lives over here. We have scrap paper that's printed on one side, blank on the other. Graphs of a single quadrant. So if we're only doing one quadrant graphing, and you can do a lot of these real easy, they're already laid out, everything except for number. And then graph paper. So we're going to use a lot of graph paper this year. If this stack ever runs out, let me know. I've got, I would say an infinite amount, but that would be a lie. I've got a lot. A lot. Exactly. Well, we haven't found the end to space yet, so. Alright, so we have another UQBing video just to start. It's only 2 minutes. I promise you will survive. So this one, oh, by the way, to start to train people, if anybody is sitting over on that side of the room, because I hated the feng shui when I first got hired, I moved where my computer is. This is the amplifier for sound, and I took the Post-its off, but I'll put new ones on. This big black button's the power button, and that's all you got to do to turn it on. So if people are ever over here and I say, hey, will you turn on the sound, all you got to do is hit the power button.
The button of power.
The button of all power and sound. Alright, so today it is going to be ever more important to believe in yourself. So you already have the handout. You don't quite know what we're doing yet, but it's going to be really important that you believe in yourself as we go, because I think today is going to be a slight struggle. So let's check out the UQBs again.
This is really hard, but I believe I can finish it. I'm going to keep trying different things. So exciting. The Google's happening right here. They're trying to work on a problem. So exciting. Hey, what are you doing here? Watching your super awesome brain grow right here, right now. Really? Yeah. You believe in yourself and you're working on a really challenging problem. What does that mean? working on a challenging problem, but for some reason you don't believe in yourself. And that means that your brain won't grow as much.
What? You totally have the potential in yourself. As long as you start believing in yourself, your brain will grow a lot more.
Wow, I can do this. I really believe in myself now.
Do you remember in the last film we showed you that when you make a mistake, your brain grows? Well, the scientists actually found this. These are heat maps of brains of people making
So check that out. That's real.
And these brains are the people who have a growth mindset. They believe that they can learn anything. And their brains were on fire with brain growth when they made a mistake. But the people who had a fixed mindset, who thought their intelligence was limited, their brains didn't spark and fire with growth as much when they made a mistake. And this is really important for all of us, teachers, students, everybody. If you go into a hard situation believing in yourself, thinking, I can do anything, and then you struggle or fail, your brain will grow more than if you go into that hard situation thinking, I can't do this. So it's really important always to believe in yourself. It's also really important to struggle and fail sometimes. Those are the best times for brain growth.
So, did you pay attention to those heat maps? Those are what I think is really cool. So, we will talk this year about fixed mindset versus growth mindset. A growth mindset means that you believe you can grow. So, sorry, I'm just checking a letter group on here. I'm in the last period of the day. Yeah, so from like 12:55 to 1:40. So this is not much activity going on. This is like registering how much blood is passing through. I have this done on my heart. We'll talk. I have a little heart issue thing. I'll miss a day in school in January to go down to OSU. This is just the difference of believing that you can grow, not even believing that you can solve the problem, but just believing that you can grow. So your attitude makes a huge difference on your ability, or at least like the benefit that you get from whatever it is that you're doing. So let's check this out. So check out your handheld. So, I don't know why I turned that off now. How do we see this pattern growing? So, for a moment, think at your table by yourself. You can grab colored pencils if you want to color code things. There's two sides to your handout. So the one side just has one of the set of growing stairs. The other side has the same thing multiple times. So if you decide to use colors, you could try it a few different ways. You could grab graph paper and try this a few different ways. So here's my situation for you. I work at a rock wall, in case we haven't talked about this yet, which I doubt it. But at that rock wall, one of the things that we have is a bunch of milk crates. I'm talking like a lot, like a closet full. And when we start playing around sometimes, we'll build stairs. You put down one milk crate, step onto that. You put down 2 milk crates then, step up onto that. You put 3 milk crates, step up onto that. And you work your way up, and eventually you're pretty high up. So, we will then ask some leading questions about as I build my staircase, because you can see we're essentially building a staircase here. But, so, what do we notice is happening with the pattern? What relationship do we see? And these are like ponder on your own, then you're going to talk, and then we'll come together. So this is, remember, we're all transitioning. This is not math class how it used to be. Do you see it growing up, out, from the bottom? And could we use colors to help us out? So let's say 2 minutes on your own. Color code things. Think about if you're going to have to explain your thoughts to your partners, your teammates, you got to kind of collect them first. So think about those things, color code or whatever, take a couple minutes. Then we'll let you talk with your team. So colored pencils are all right up here. We've got a random supply right in the cup, or organized, but if you get it from the organized, you have to reorganize it when you bring them back. So grab whatever colors you want from there. You'll start to learn where all our resources live as we go. This is like resource wall over here with just bins of stuff. And then the questions I'm going to ask you to eventually discuss is those. And I'll still give you 2 minutes, like once you grab your colored pencils and stuff. But what would the figure 10 look like if we now see figure 1, 2, 3, 4, What about figure 55? And if we had 190 squares, could we make one of these figures? So you visualize it growing outward, like on the diagonal.
Yeah.
It's different than my brain, but I like it. Anytime I can make straight lines, that's just how my brain works, but it's interesting to see how it is. Yeah, see, like I would work the way that you're doing it in my head. I see either of those, but I don't see like that. Oh yeah. From like the math side of things. All right, go ahead and talk with each other. If you have differing ideas, that's fine, that's good, but you all have the same goal of saying, what would figure 10 look like? What about figure 55? And if you had 190 squares, could you build one of these figures? And really what we're thinking about is how many total milk crates would I need to build that? So if I wanted to get up 10 milk crates high, and I had to do it the stair-step method, how many would I need? If I wanted to get 55 milk crates high, which would be really dangerous, but that's okay. How many milk crates would I need? And then if I had 190, how high could I go? So think about it with each other. Talk with each other.
Like adding each one on to the figure 3 or figure 4. Like, so figure 4, they build a stack of 4, and then you add all the rest in figure 3. Oh yeah, so I was kind of like that, but I added them diagonal. So like every time, like it was 3 to 5, and you have like 5.
So wait, originally, how did you see it grow?
Adam, I figured out what 10 is. Oh yeah, you did it like.
So you were saying the growth is here, which is interesting because they saw their growth from the top and the right.
And then that's what I came up with an idea was that every time it adds the same amount of blocks for the number of the figure. So that's why I was thinking
So
10 would be 5, 6, 7, 8, 9, 10.
okay, so figure 10 adds 10 to what?
65 is 11, 21.
So my real question, because then I'm going to walk away. My real question is going to be: is there a quick way to do this without adding all? Because what about figure 55? Come on, I don't want to add all those up. So our real goal is: there a quick way to do this? So we say from the diagonal. So like I was saying, our real goal is 55. Is there a way to think about like figure 10, figure 55, those things?
So figure 55 would have
individual set.
wait, I see it. Wait, how many? 10 would be, if you're using my way, it would be, or your way.
Okay, so you have
10.
10 on the diagonal, 10 on the vertical, and 10 on the horizontal. But the thing is, this is on the
Because
vertical,
there's 10
and this
high.
is on the horizontal, and that. So you're actually double counting some of those things.
Yeah.
So here, you call 10 here. Really, you only have 9 more. You know what I mean?
I know, I hate that.
Make sure that they're understanding what you're saying. You can use graph paper too if you want. You don't have to draw them. Guys, graph paper is pretty beneficial here to help you visualize some of this. Please make sure you put your name on anything we give you. First name, last name, and letter group is always beneficial too.
Well, right now we're like, what is this normal time? 2A?
So let's chat whole group for a minute, and then we'll release you again, and we'll kind of do this back and forth. So I heard a lot of good conversation. I'm loving it. I appreciate that you guys are chatting with each other and exchanging ideas, building good systems here. When we think about figure 10, can anyone describe to me what that's going to look like and how many squares it would have? I mean, look like is the first part, then we'll ask how many squares. Can anyone tell me what it's going to look like? Oh, come on, people know. I walked around, I know you know. Then.
Well, figure 10 is going to look like figure 4, but you add a row of 5, 6, 7, 8, 9, and 10.
So there'd be, I can't write on this. That's why I said jump to the other one. So I would have a 5, and then a 6, and then a 7, and then an 8, and then a 9, and a 10. Okay. So how many squares does that make me have?
55.
55. Now how'd you figure that out?
Well, I started from figure 4, and I knew that was 10, and then I made a block. Equal to how many I have, which is 4 high, and then I added as much as it needed to be 5, 6, 7, 8, 9, 10.
So what about then figure 55? Yeah. Help me with your name again, please.
Alex.
Alex. Alex, what do you think?
Do I have to do both looks or just the
That's not good. My smart ink is not cooperating right now. I might not be able to write on the board, which will be interesting for today. No, I was turning my document in here. Sorry, so Alex, what was that?
Like, do I have to do both looks and...
No, you don't have to do both.
Okay, so, well, basically I'm just going to say how I got the answer.
Okay.
So basically, since it's figure 55, I started from figure 10. Instead of saying that was 55, I multiplied 55 by 5, because for 50 groups.
Well, what do you mean groups?
Well, I mean, if there were like, if figure 50, it would be like 5 times the amount or so of figure 10.
So, okay, I'm just trying to make sure I understand this. So you're saying figure 10. So let's talk about some notation. So if we're back here, let's go ahead on the side where we just have the big The big squares to stairs. Everyone wants to flip to that side. So when we talk about figure 10, and we talk about how many squares it has, we can use function notation. So we're going to introduce this. So we would say the squares at level 10. So up like here, we have the squares at level 2 equal, how many squares do we have in level 2? 3. The squares, meant for that to be an S, the squares in level 3 have 6. The squares in level 4 have 10. Interesting. So, since my smartboard's not working, we're just going to keep going old school today. So actually I'll throw this up onto the TV screen so you can see my thought process then. So if we want to look at how we move, how we get from one figure to the other, what is it that makes this process difficult? Oliver? So if I'm thinking, so we start with 1, right? We know that. So S of 1, the square's at 1.
The process it's made hard because from figure 1 to 2 it adds 2 blocks because it's the second figure.
Okay.
And figure 3 adds 3 blocks, so 3 plus 3 equals 6. And then from figure 3 to 4 it adds 4 because it adds the same amount as the figure number. So you can't really multiply because if you multiply figure 10 by 5, you don't have the numbers like it'd be 55 plus 55, but you're not accounting for it. The next one is 11, so you add 11.
Yeah. So let me try to visualize, because exactly what you said is exactly right. Let me try to visualize why multiplying by 5 doesn't quite work. Imagine with me that this desk is my figure 10. Okay, I've got 1, 2, 3, 4, 5 blocks, 6, 7, 8, 9, 10, right? We'll say this surface is 10. You just don't tell people that I was calling my desk. I'm not supposed to. So I walk up 1, 2, 3, 4, 5 blocks, 6, 7, 8, 9, 10 blocks, and then if we multiply that set by 5, I then start over and go 1, 2, 3, 4, 5. Now, if I went to stack the sets and I say I multiply by 5, then this staircase that went up here and this staircase that went up would fit on top of each other and just make a square. Like a big old square.
So then you couldn't get up it.
I couldn't get up it.
It's supposed to gradually build you can't multiply because it'd be multiple or if not.
So the issue is that we're growing more and more and more as we grow, right? So the inconsistent growth is our, but you said something, Zin. You said something really interesting about, like, you were kind of making some kind of rule. The rule is it grows as much as, ooh.
Because, like, if you look at it from figure 1 to 2, it adds 2 to the left side of figure 1 because it just goes 1, 2, 3, 4 up the left side.
So figure 10 is going to add 10. So let's go ahead and say, okay, 10 will be added to, let's go ahead and jot this down on our paper. 10 is going to get added to what? Well, we know that it would add to figure 9. Well, the problem is figure 9, that squares in 9. Well, how do we get 9? We add 9 to figure 8. And how do we get 8? We add 8 to figure 7. And so, crap, this is going to take forever. And then figure 55 is going to take even longer than forever. This is really tough. Oh, it's possible.
No, longer than forever.
Oh, no. But I like saying things that will hopefully at least crack a smile. You don't have to enjoy my math class, but if I at least get you to smile, then I've made a small victory. So hang on to this sheet. Hang on to this, and let's switch over to growing squares extensions. Switch over to this worksheet. How long? I have till 50? Sweet. So you have the original growing squares problem up here. Ignore it for right now. It's just there to be a reference point on the paper. So I made this easier, and I said, you know, if I take out the middle part, then what do I have left? Well, I'm growing up and out. So if I take out the middle little part, well, I can't climb the stairs. Don't worry about that now. But now what do I really end up with? L's. So now as your group, look at this situation with stage 1, stage 2, stage 3, and stage 4, and figure out if there would be a way to represent where we'll be going with stage 10 or how we get there. Is there an easier way to do this than the stairs? Think about everything we did with this problem, and I would kind of draw it out the same way maybe. How many total squares do we need? What's the change when I go from one stage to the next? So think through this stuff and see if you could figure out an easy way to determine how many squares would be in figure 55. Now this is a different set, so you might want to change colors or something like something that will help your brain realize this is a different set.
How do you use this? Well, like, I'm looking at this, right? So 8, 4, 9, so we just do 5 like that. Yeah. I see it. I see it as like stage 3. There are 3 blocks underneath because this block can only be counted once. So if we count this way and that way, that block is counted twice. Oh yeah, so it's like 4, 0. So and then they just add the number lower, so then you add 3. Yeah, that's what I'm saying.
So you just talked about a block counting twice.
Yeah.
If you don't want to look at that block twice, so you were saying stage 3 has 3 on the bottom. Right, but then so if we take those away, it has 3 on the bottom and 2
on the top.
So then let's play with that statement on the next one. You guys keep doing your thing. You don't have to listen to it. So stage 4 has 4 on the bottom.
So like I see it like 4 on the bottom and then the last one on the top.
Ooh, so the stage you're at number plus the previous number.
Yeah.
That's kind of what you're saying. So
yeah.
play around with that.
Yeah. Now I can figure out the film. Oh yeah. Well, I guess no, this like this right here.
You're not supposed to be talking about that problem still.
Okay.
Over here.
It's another
Figure this out.
topic.
How are you explaining that?
What?
So how do we figure out how many stages?
Well, no,
It would be 109.
yeah. Okay. So
Figure out more efficient way.
well, this part will be 109. Like L will be 109.
So don't just say something, figure it out. You're on the right track. Take that and run with it. Talk with each other. Stay on this one for right now, okay? Don't go back to the staircase yet.
Yeah, that's what we're trying to figure out how much it adds in the so, okay, so in the middle here, I see it adding as many blocks as it was the last time. Because in no, like 3. Yeah, but I know. That's on my plan. I don't know. Okay. Yeah, she grabbed
So
it.
what we're trying to do here
Who wants graph paper?
Okay.
We already have it.
Dude, do you
So
want
try
graph
to make a
paper?
rule that references back to the beginning. Not like references to stage 4, references to stage 10. So references all the way back to the beginning and then some consistent rule. If you think you got done to L, you can move on to the weird Tetris shape.
Wait, so you
Tell me
give
this
us
doesn't
like
make
3
you think of
times?
that. Come on.
It does make us more than 1 and then has 3, so it doesn't work. It goes up by 2. From 3 to 4 goes up by 2.
That's the point. It looks different. So I want us to have time to discuss the different ways that we're looking at this. Does anybody want to come, and you can just use the dot camera and show your paper. Anybody want to come and explain your thinking to us? Now, for the L one, right? You're going to bring your paper, or you're just going to show online? That's fine. I got plenty of these.
Okay.
They got Sharpies here if you want to color or pen.
So as you can see, well, starting from stage 1,
Give
like,
Alex your
as
respect,
you can
please.
see, we only have like, well, 1. But when we look at stage 2, it's like figure 2 from the staircase. But when we look at 3, it's different. It just keeps adding 2 blocks on the end. So what I did was, since this was stage 4, I subtracted 55 from, well, 4 from 55, and I got 51. Like to show how many more stages we have until we get to 55. Multiply.
So, hold on, back that statement up, Alex. So the connection that I think you kind of breezed over is that you had identified what about the bottom?
That it keeps adding. Oh,
The number of squares in the bottom, across the bottom.
That's how many stages we have
That's
left.
your stage number. So what Alex is saying with the 51 is we need to change stages or add 51 more blocks on the bottom. People get that? Okay, go ahead.
So then I just multiplied 51 by 2 because it just keeps adding 2 every time. And I got an answer of 201.
102.
Oh yeah.
You're good.
So then I counted the blocks for stage 4 and got 7. So added 102 and 7 to get the answer of 109.
Very nice. Anyone else get 109 but in a different way? You want to share it?
Or maybe it's like faster.
Yeah, take it up. Because we want to write a rule that could work for any stage. So Alex, I love your rule. But if I tell you to go to stage 8,742, it might take you a little bit to figure that out. We want a really quick way.
Well, I just figured out that the bottom is the stage number from like this part right there. But then this part, because you can't count that one twice, these 3 is always the stage before it.
So
I just added 55 and 54.
let's start calling the stage number, like in math, because that can change. What do we do with things that can change in math? We use variables. What could we use for a variable to represent the number of the stage? We like better x or really n. Number of stage. And you can use whatever you want, but we often, when we're doing things like this, use n. So let's go ahead and say that it is stage n, because we used s for the number of squares, so let's not use s for anything else. So you're saying that this bottom is always n.
Yeah.
And then the vertical addition is n minus 1. Always. Because if there's 8 across the bottom, there will be 7 up. So let's write this out. You want to do it or me too?
Yeah, you.
Okay. So what you really said without realizing, without writing it out, is that the number of squares at stage n will be n on the bottom plus n minus 1. Let's go ahead and show that somehow on your page. So I'm going to color code that these are always n, and that these are n minus 1. And you can make yourself a little note that n is stage number. Hashtag is the original number symbol. pound sign also. Had many names before it was hashtag. So then really, what we would have at like stage 55, you just said, was 55 plus 55 minus 1. Well, 55 plus 55, then minus 1. Could I do anything instead of saying 55 plus 55 minus 1? Naya? So I could actually do what we call combining like terms, and we'll talk more about this later. This n and this n are like each other. They're both n's. These parentheses, I can't do inside the parentheses because I don't know, quote unquote, I don't know what n is, right? It's a variable. So I take away the parentheses, and I just have n plus 1, and exactly like Naya just said, I can really just say 2n, not plus 1, sorry, that was minus 1 up there. This should be minus 1, I'm going to rewrite this. The squares at stage n is 2 times the stage number minus 1. Did anyone find that or anything like that in a different way? What do you mean, kind of? Do you want to come up? Or?
Well, I just basically said if you add the figure number to the base on, this is what I called the, like what would be the beginning stage 1.
Yeah.
And then added on from that the base. And then I said you would just add the base number to that and then subtract 1 from each axis.
Okay.
So it would be 54 on the y-axis and 54 on the x-axis, and then the base would serve as 55.
Okay. Yeah, you're thinking a little deep. I like it, but it's almost a bit more complicated than it needs to be. It's good if you get it. It's good if you get it. But it might confuse other people. I like it, though. Let's look at this next one. As I was walking around, a couple different people stopped me. They're like, yo, Hudson. So, actually, any of those people that stopped me want to tell me what you said? Then?
I said that the like figure for this is kind of the same thing as the L. It just adds 2 to the right every time. So like in the first one where it adds the figure number to the left, this time it just adds 2 to the right every time.
So if we look at how many squares, 1 square, 1 square, both in stage 1. Stage 2, 3 squares, 3 squares, organized the same, just kind of turned a little different. Stage 3, this is where we get the weird Tetris shape. 5 squares and 1, 2, 3, 4, 5 squares. It's the same pattern, just represented differently. This is what I call the disappearing stairs, or the dangerous stairs, because it's the stair step, but now instead of taking out the middle part, we took out the bottom corner part. Do we see how we still have the original stair step problem, and we still made it easier by taking out a piece of it, but now we took out this piece. So still, we have 1, then 3, then 5, then 7. So every time we move, we add 2. But I heard somebody over here, what's your name, bud? Bougandier. So I heard Bougandier say, well, you just add 2 every time. And I kept challenging people by saying, what if I asked you for stage 8,742? For some reason that number's in my head today. So hold on. So we add 2 every time. Every time what? What do you mean by every time? Every time we... How do you know what I'm getting at? How is it that we add 2? What happens that grows my shape?
You have to like get to the top and you just kind of stuff.
Okay, so if I say that this is level 1 and this is level 2 and level 3 and level 4, to add 2, I have to change my level, right? So I can't just say I'm at level 1 and I'm going to add 2 and I'm still at level 1. Right? If I add 2, I've changed my level. I've moved. Okay, do we get what I'm saying?
Yeah.
So when Moving Deer said all we do is add 2, all we do is add 2 for every level we've gone up. Right? So if I've gone to level 8,742, how many levels would I have to have changed to get there? If I start at level 1, how many changes does it take me to get to 8,742? Alex did this math earlier on, right over here.
8,741.
Yeah. He started at level 4, but I don't want to start at level 4. I want to start at level 1. So to get all the way, I wish I had my paper, to get all the way to level 8,742, we started at level 1. I changed 8,741 times. And Moving Deer said all we got to do is multiply that by 2 to know how many we've added. And what he didn't realize he was doing was saying to find the total number of squares at any level. I know that I started with 1, and then I added 2. I'm taking information that I heard from you guys as I walked around. But I add 2 for every time that I move or change or increase my level. So at stage 1, how many levels have I changed? None. We start at 1, right? So the problem is I can't add 2 if this is level 1. So S of 1 needs to still equal 1. Well, crap, I can't add 2 and get that as my answer. So I could say 2 for every level that we move, but that doesn't work. So if we think back to the problem that we just had up here, what might we need to be bringing in? Instead of just saying 1 plus 2 times n, what? That would equal level 2 if we leave it just like this. So if this is 1, then we're actually on level 2, you're saying? Okay, Zen.
So I came up with a way to solve this. It's kind of like the L, but it's all the lower blocks on the lower part is equal to the previous level, and the top blocks are equal to its current level. So what you do is you multiply, or not multiply, you add them together to get the amount of the stage.
You know what you just told me? This right here. You just told me that right there again.
Right. And
Well, so I love that, but we're kind of talking in circles then, right? Which is fine, because we do that in math a lot when we're trying to solve stuff.
But for 1, because it's only 1 block, you can't add anything else, so it's just 1 for the first.
So what you're saying is this has to just be 1. What can I make n to make the multiplication to make this turn into 0? N would have to be 0. But I know that n is 1. What do I do to n to make it 0? I need to take 1 away from it. So what we actually end up with is 1 plus 2 times 0. 1 minus 1 makes 0. That cancels out that from doing anything, and we're good. We get 1. And again, this would actually turn into the same thing as that if we did the distributive property, which we'll talk about this year, and then combine like terms, we would end up with the same formula. If you so choose to step up to the challenge, the back of this is your homework. Now, this is not like real homework that I'm going to collect and check, but we will be coming back to this later in the year. Also, remember, we did not solve this. We have not totally solved this yet. So all we know is some things that we talked about that we're going to keep increasing by more and more and more every time we go. That figure 55 is going to add 55 onto 54, but we don't know how big 54 is. So have a wonderful weekend. Play with this if you want to. Do not let your brain sit and do nothing all weekend. Give your brain some kind of workout. Thank you guys very much. Have a wonderful day.